In this video, we're going to take a look at how to find an angle or angles given a particular ratio. So solving a trigonometric equation means to find that angle, which gives that particular ratio. Now remember that for each ratio, the trigonometric functions are positive or negative in two quadrants, and therefore there will often be two solutions for each ratio. We're going to take a look at two situations. The first one involves finding the angle without a calculator, and then our second one will involve using the calculator to find the angle. Now, when you're given an exact value for the ratio, you can use the special triangles if the ratios pertain to one of them. So how do you know? Well, when you take a look at the ratio, does it actually satisfy one of the triangles? So let's take a look at this first example. So we have sine theta is equal to a half. And if I recall correctly, there is a triangle that involves 1 over 2 for sine theta. Now, I can see that the half is positive, and I know that sine is positive in the first quadrant and the second quadrant, because remember that all students take calculus, and so in the first quadrant, all of the trig ratios are positive, and in the second quadrant, sine is positive. So what I'm going to do is I'm going to graph or plot 1 over 2. So I'm going to draw two angles, one in quadrant 1, the other one in quadrant 2. And I'm going to draw a triangle that goes to the x-axis. Now, based on theta, which is right here, because we always measure the angle with respect to the x-axis here, in standard position, we know that sine theta is equal to 1 over 2. Now the other angle is the one over here. And I'm actually going to outline that in red. And again, the ratio is going to be 1 over 2. And that's based on this angle here. Now this angle for both of these triangles, we can call that the reference angle. So the reference angle, in both cases, if you recall the special triangle, when this side's 1, this side's 2, that angle that has to be here, this reference angle, has to be 30 degrees. And that's based on memorizing that this is 30, this is root 3 beside it, 1, and 2. So now that we know that the reference angle is 30, we can find our two angles. Now the first angle is in the first quadrant, and it's the same as our reference angle. The angle in quadrant 2, this red one here, we need to find that by taking 180 degrees and then subtracting the reference angle, which will then give me this red arc, which is the angle in standard position. So that's going to be 180 minus the reference angle, which will then give me 150 degrees. So my two solutions are 30 degrees and 150 degrees. All right, let's try this again with a different example. So here we have cos theta is equal to negative a half. So seeing that it's a negative a half, and we can also see that the ratio is 1 to 2, I'm going to plot my two angles in quadrants 2 and 3, because that is where cosine is negative. So it's negative in quadrants 2 and 3. All right, so again, I'm going to draw my triangle towards the x-axis because angles are measured one over here, and the second one is measured over here. Now these triangles should actually be the same size, but this is a very rough sketch here. All right, so based on cosine, this is our adjacent. So the 1 is the adjacent, and the 2 is the hypotenuse. So knowing that that right here is my reference angle, the 1 is going to be this value on the x-axis, and the 2 is the hypotenuse. Now, if you want, you can also label this as -1, so that you can see that that's why this is negative. All right, So based on memorizing my special triangles again, since this value here is -1, I know that my reference angle equals 60 degrees. Now this time, it doesn't happen that my reference angle is one of my solutions. So my first angle, this one here in blue, the blue arc, that's going to equal 180 and then minus this little angle, my reference angle. So 180 minus 60, that's going to give me 120 degrees. To find the second angle, it's this angle all the way in red, all the way past 180. So we need to take 180, and then this angle in here that forms the triangle happens to also be my reference angle. These two reference angles are the same value of 60 degrees. So we need to take 180 and add 60 degrees to get 240 degrees. Let's take a look at a couple more that involve tan. So tan theta equals 1. Now I recall that this is going to be 1 over 1. And that is my special triangle that involves the 45-45 triangle. Now tan is positive in the first quadrant and the third quadrant. I'm going to draw the triangle to the x-axis because this is where I measure my angle, and this is my reference angle. This here is also my reference angle. Based on tan, tan is my opposite divided by my adjacent. So my opposite is going to be 1, my adjacent is going to be 1. And that will be true for this triangle in the third quadrant too. Now the reason that we can say that one's positive is that this side length can be -1, and the y value coming down is also -1. So -1 divided by -1 is +1. Remembering my special triangle, since this is 1 and 1, this will be root 2, my reference angle is going to be 45 degrees. Now in this case, the 45 degrees, because it's in the first quadrant, and it's also the same as the reference angle, my first angle is going to be 45 degrees. My second angle in the third quadrant passes 180, and then I have to add the 45 to get the full arc. So this will be 180 plus 45 degrees, which equals 225 degrees. Now this last one here is a little bit different. Notice it says that tan theta equals 0. We can still write this as 0 over 1, so we give it a ratio as a fraction. Now, not really knowing where this is, let's say that I wanted to draw a triangle. So this would be my opposite, the 1 would be my adjacent. Let's just draw it in the first quadrant here. So, seeing this, my opposite has a height of 0, my adjacent has a height of 1. Now, that's not the only triangle I can draw. I can also draw one maybe in the second quadrant. Or I can even draw it in the third quadrant or fourth quadrant. But it doesn't really matter because it's always going to be a height of 0 divided by 1. In this case, it's going to be -1. Now, if you think about it, if the height is 0, that means that the angle has to be right here on the x-axis. So my first angle is going to be 0 degrees. On the left side here, if the height was 0, and this height was 0, that means that my angle has to be fully on the x-axis as well. Now this red one starts at 0. Remember, this is 0 degrees, 90 degrees, and this is 180 degrees. So to get to this angle pointing to the left, we need to go half an arc of 180 degrees. So the second angle is 180 degrees, giving me these two angles. Now the second part, what I want to look at is how to use the calculator to find the angle. So make sure that your calculator is in the correct mode. Make sure that it's in degree mode and not radians or gradients. And you're going to activate your calculator to find the theta by pressing the shift, inverse, or the second button, depending on what kind of calculator you have. So we're going to do the same thing as above because it's the same idea. It's just that we don't have a ratio that is a fraction. This time we have a decimal. So cos theta is positive, and again, cos theta is positive in the first quadrant and the fourth quadrant. Now we don't know what the angle is, but I can draw the triangle here. And this reference angle we can find by typing this in. And what we're going to type in is theta is equal to cos -1 of 0.468. So what I do when I find that is actually I'm finding my reference angle. So activating the cos -1, that's called the inverse. And we can't, so cos is not a number, and we don't divide by cos, but we need to activate the inverse function to find the angle. So my reference angle, when I type this into my calculator, gives me 62.10 degrees. So you should try this as well on your calculator. To find the second angle, which is from here in standard position all the way to the fourth quadrant, I know that my reference angle is here in the first quadrant and my reference angle is here in the fourth quadrant. So to find the second angle in the fourth quadrant, we can go full circle of 360 degrees, but then we need to minus that reference angle of 62.1. So this gives us 297.9 degrees. And there are my two solutions. Let's take a look at one more. So in this case, sine theta is negative. So sine theta is negative. It's negative in the third quadrant and the fourth quadrant. Now, I don't really need to draw the full triangle, but what I need to know is I need to find this reference angle here. Now, whenever you are finding the reference angle, you need to type in the inverse of the ratio, but you need to type it in as a positive value, because remember that the angle is always going to be positive. You can try typing it in and see what happens when you type in the negative, but you won't get maybe the same thing. So we type it in as 0.846, positive 0.846, and you're going to get a reference angle of 57.78 degrees. So I'm going to write this down because I think this is really important that you remember to type this in as a positive angle when you are trying to find the reference angle. Okay. So now that I know that this is 57.78 degrees here, this here is also 57.78 degrees. So to find this angle here in the third quadrant, my first angle, I need to go 180 and then add my reference angle. And that gives me 237.78 degrees. To find the angle in the fourth quadrant, I need to go full circle 360 degrees and then go back and subtract the 57.78 degrees. And that will give me 302.22 degrees. And these two are my answers. So remember that most of the time we do have two angles because there are two quadrants where the angle is going to be positive and two where it's negative. So you can see here, sine is negative in quadrant 3 and 4. So we're going to have two angles that give us that negative ratio. And you can type both of these in to double check that you actually get negative 0.846. In this first example, cos is positive in the first and fourth quadrant. So when you find your angle, you're going to find two angles as well. And again, you can check that by plugging in these two angles into theta here and going cos of those angles to make sure you get 0.468.